The power that's inside. 11.3 circles and sectors. All right, obviously we know what circles are. Let's go ahead and do the area of a circle. You guys learned this in probably the 6th or the 7th grade. Area of the circle is equal to pi r squared, r being the radius. Let's do an easy example. Here we have a circle. It is labeled 16 inches, but the question is, what is the labeled? Is that the radius or is it the diameter? When they go all the way across, when they draw it all the way across and they write it right in the middle, that means it is the diameter. And you should know that half the diameter is the radius. So we're actually going to use 8 for the radius. Area equals pi times 8 squared. 8 squared is obviously 64, so you can leave your answer as 64 pi inches squared and just leave the pi in there. Sometimes on some standardized tests, they might want to make you use the pi button on your calculator, so make sure you can locate the pi button on your calculator and use that button. Don't just use 3.14, that's a very rounded answer for pi. Definitely find the pi button because the button will use all the decimals of pi when you use it, all right? Area of a sector. What is a sector? A region of a circle that is bounded by a central angle and its intercepted arc. So basically, a sector is a piece of pie or the slice of pizza. So that's what a sector is. All right, so if I want to find the area of it, how do we do that? All right, so obviously we know how to find the area of a circle, but then we want to just find a fraction of that circle. All right, and so you should think that the formula requires using the whole circle and then a fraction of it. And so there it is. This part is the area of a circle, pi r squared, and this part is the fraction that we want. All right, the MAB stands for the measurement of arc AB. So that measurement is also the same as the central angle right here. All right, so it's that angle divided by 360 and then times the area of the whole circle. Let's do an example. Let's go ahead and find the area of the shaded sector. It's that green sector. We have the radius is 5 inches. We have the central angle is 30 degrees. So plug everything into the formula. 30 is the measurement of AB over 360 times pi times 5 squared. You can go ahead and punch all of that into your calculator to get 25 pi divided by 12 inches squared. Again, I left my answer in terms of pi. You can just use the pi button and get an approximation if you want, depending on what they're looking for. Here's another example. Find the area of the shaded sector. Notice this one, the shaded part is the bigger part. So you're not going to use the 85, but instead you're going to use 275. It's the other side of the angle. All right, so just pay attention to what part they want. In this case, they want the bigger part because the bigger part is shaded. And so you have to take 360 minus that 85 to get that 275. And then everything else, punch it in. Look, in this case, I used the pi button to get 117.5916 inches squared. Going backwards, what if they give you the area and you have to find the radius? So you have to go backwards. Well, use the formula. There it is. Fill in everything you know. You know the area. You know the measurement of arc AB. The only thing you don't know is R. So let's fill it all in. Go ahead and you can actually punch all of this into your calculator to get a decimal, but I'm going to show my work. I'm going to go take one step at a time. I'm only going to get rid of the 360 right now. To get rid of a 360, move it to the other side by multiplying both sides by 360. Then I'm going to divide the 120 to the other side. And then I'm going to divide by the pi button. And then the last step is to square root that. And there we have it. Ooh, and it should say 18.1508 centimeters. All right. But again, I took every single step, but you don't have to take all the steps. You could have done all three of them at the same time and then divided it over. All right, we only got one slide left. Ooh, this one's a tricky one. Find the area of the shaded region. So it looks like a circle, and then a square has been cut out of it. So the way you do that, to find the area of the shaded region, it's basically the area of the circle minus the area of the square. All right, let's go ahead and find the area of the circle first. Area of the circle is pi r squared. The radius is 10. Square it and multiply it with pi using the pi button. I get the area is 314.1593. Let's go ahead and find the area of the square. This one's a little bit more tricky. You have to remember that the area of a square is base times height. All right, but neither the base or the height is given, which makes it a little bit tricky. Here's what you do. You go ahead and draw this piece in. It's supposed to be straight. We know that this is 90 degrees inside a square. And then because I just drew that in, this is now 45, 45. We now have a triangle inside that is a special right triangle, a 45, 45, 90 degree right triangle. You have to remember the rules of that. If one leg is 10, the other leg is also 10. But more importantly, the hypotenuse, this right here, is, do you remember? 10 radical 2. All right, which means this side is also 10 radical 2. All right, so that required a little bit of work, but there it is. Area of a square is 10 radical 2 times 10 radical 2. You can do this all on the calculator, or you can do it in your head, because this is a little bit easier to do in your head. The area of the square is 200. All right, to get the shaded region, it is the area of the circle minus the area of the square. And there we have it. And I keep forgetting to write the units, but this is units squared. All right, there we have it. Go ahead, try your homework.